Hello everyone, welcome to the part 3 of our lab 1 in advanced digital system design. Here we are discussing the design of the digital clock using the onboard 7 segment display as well as the PMOD 7 segment display. In the previous two labs, we discussed about the how to connect the 7 segment display and the PMOD 7 segment display and how to generate the seconds as well as the minutes counter. In the task 3, we are going to extend our previous lab where we are going to use the push button and the switches to control the clock. Here basically we are using the push buttons and the switches to set the minutes as per the requirement. For example, by making the switch is equal to 1, by using the upper and the lower push button, we can increment the minutes counter so that we can set the minutes counter to any value. So you can increment using the upper push button and decrement using the lower push button. This is possible only when the corresponding switch is 1. If the switch is 0, then this push buttons will not work. So now the switch is 1. So you can see that the push buttons are helping us to set the minutes as per the requirement. And now you can see that after the seconds reaches to say 60, then your minutes will be incremented by 1 as per the desired functionality. Okay, so this lab needs the use of the push buttons, and whenever you have to use the push buttons, you need to be aware about the push buttons debounce. For example, when you push the push buttons once, in the ideal case, you should have the increment by 1. So when you push the push button one more time, it should be incremented by 2 and so on. And then you write a code which is there on the left hand side. You can say that every positive edge on the push buttons if your output is incremented by 1. But this circuit doesn't work in the reality. In reality, you will see that if you implement this circuit, whenever you press the push button, the increment in the counter is by some random number. So every time this number is also changing. So you can see that in the first case, it's incremented by 5. In the second push button, it is incremented by 7. And this happened because of the push button debounce. So because of the low quality push buttons, sometimes when you push the push button, the output of the push button is changes between the 0 volt to the maximum say volt, which is 3.3 or 5 volt, multiple times before it settles down to the maximum volt. So you can see that the output of the push button switches between the 0 and 1 multiple times before it settles to 1 when you press the push button. And to avoid this, we need to use the debounce circuit. So in the debounce circuit, we will sample the output of the push button using the clock, and only when the push button output is 1 for certain number of clock cycles. So here you can see that we check the output of the push button for 3 clock cycles, and if it is 1 for 3 clock cycle, consecutive clock cycle, then we make the debounce output is equal to 1. So then only we know, we make sure we announce that the push button has been placed. So this is the push button debounce logic which we need to include in our Verilog code. So when you press any of the push buttons on the FPGA board, they may bounce slightly for a few milliseconds before settling down. This means that instead of the input to the FPGA going from 0 to 1 cleanly, it may bounce back and forth between 0 and 1 for a few milliseconds. So what we do, we have the 3 stages of flip-flop, and we can see that we give a sufficiently high speed clock, and then the input of the push button is passed through the 3 flip-flop. Only when the input is 1 for 3 consecutive clock cycle of this C clock, then only the output is 1 by using this AND gate. We need to make sure that this out clock frequency C clock must be low enough that the switch bouncing is over before the 3 clock period. So usually around the 200 to 250 hertz clock is sufficient for the switch debounce circuit. So the logic for this circuit is very simple. You have the three flip-flop, and the output of the first flip-flop is passed to the second, second is passed to the third, and so on. And at the end, you have the combinational circuit to do the AND operation. So you can see that this is my flip-flop logic, three flip-flops, and this is my combinational circuit logic, which is the AND. Now you can see that here, this is the output P, which I got it by using the circuit which I discussed which we using the Verilog code, which we discussed in the previous slide. But sometimes what we want that we want the output in terms of the clock pulse. That means the output will go only once from 0 to 1, and that it will remain at 1 for one clock cycle. So this is the one clock cycle, and it will come back to 0. So every push of a push button, we should get the clock pulse. So how to modify the previous code to get the circuit? So this is your previous code. So where you are getting the continuous one as long as the push button is pressed. So we want a one clock pulse at every press of a push button. So how we can modify the circuit? It's very simple. What we need to do is that instead of taking the normal output of the last flip-flop, we take the complementary output of the last flip-flop. And then we do the AND operation, we get the output like this. Okay, so instead of this output, we'll get the output like this, which is the clock pulse. And what we have done here, instead of the getting the normal one, what we need to do is that we need to do the inversion. So either you do it here, or you can see that you can do it here. So depending upon the where you want to do it. Okay, so this is how you can generate a clock pulse. So in our code, we are going to discuss how we included the push button and the switches, how we control the minute setting using the push button and switch input, and then how we avoided the switch debounce using the clock pulse circuit. So these are the three things we are going to discuss in our next video.